Alright, hello, my name is Reese, and I'm going to be doing problem of the week number 14 for 10.5, number 52. So what you want to begin with is taking the Laplace of both sides. And then you're just going to rewrite it. Because we know it's a linear transformation, we could write it out like this. And then we could factor out the 8 there. E to the 2 sine of 2t. And then, so let's deal with the right side first. I'm actually gonna recolor this in green. And so you just know that this guy, it's kind of just like a formula. So, squared from, which chapter is it from? Yeah, 10.4. So it's just kind of something you memorize, which is, I feel like something you just kind of do. And then it's going to be minus sy initial minus y prime initial. And then minus that guy, then equals 8. So here, we know that this guy is also from 10.5, and then you can just think of it as 2 over s squared plus 4, if you just think about the regular Laplace transformations, but then with the e of t, all it does is affect the s, so it's just s minus 1, because the exponent is just t. It's just s minus whatever number is by the t, so then technically it's just 1. So we're going to rewrite this over here as s minus 1 squared plus 4 all over 2. And then let's see, so we know that the initials are up there, and we're just going to plug those in, and then we're going to combine like terms of the Laplace of y. So s squared minus 1 Laplace of y minus, is that 2? Yeah, 2s, and then this is plus 2 equals, we're gonna multiply out at the bottom just for now, just because it's easier. You'll see in a second. So it's gonna be s squared minus 2s plus 1 plus 4 all over 16, and then you just wanna minus or plus 2s and then minus 2. So do that. Just factor out this part as well. So s plus 1, s minus 1, Laplace of y equals s squared minus 2s plus 5 over 16 plus 2s, and then you want it to be all in the same like terms, so you have to multiply the top and bottom by the first denominator, minus 2 squared minus 2s plus all over s squared. S squared minus 2s plus 5. And so then you're just going to combine that. I'm going to assume that you guys know how to multiply that out. I'm just going to give you the answer that I got, if I can find it. So then, actually here, we'll do it all in one step. So you're going to divide these two terms on both sides. So then Ly, and then the top all combined to be 2s cubed minus 6s cubed plus 14s plus 6, and then the bottom denominator is going to be s squared minus 2s plus 5, and then s plus 1, s minus 1. And so from right here, we're going to have to do partial fraction decomposition, which is a big pain, but we'll get through it. So it's going to be ax plus b. I'm going to use x's. Just know that they're supposed to be s's. They're just, I don't know, it's just easier for me to think in x's. So we're going to do that. Plus c all over x plus 1 plus... actually, here, I'll make this x minus 1. And then d is going to be x plus 1, just so that's easier. And then this is going to be equal to this. Alright, cool. So then it should be ax plus b multiplied by x squared minus 1. You could just I just combined these two terms into x squared plus 1. Just right up there, just so it's easier, like that. And then plus c times x squared. Oh wait, these are supposed to be x's on this side. I'll just do that really quickly. Just pretend those are x's. Oh my gosh, I should change that, but you know what? We're just gonna delete it. We're just gonna. So you know it's supposed to be up there. Man, I'm just okay. Well, we're doing this now. It's too lazy, but now just wasting time. And I wrote those as s's just because I was copying it down. X plus 1. Okay, cool. X squared minus 2x plus 5, and then this x plus 1 plus d. So you just want to be able to combine. I mean, you guys know how to do partial fraction decomposition, so I'll just like show you the process, but you guys know the explanation already, hopefully. And then it's going to be equal to this guy. Ooh. Cool. And so my method of doing this, just to make it a little bit faster, I'm just going to plug in x equals 1. And if you do that, you'll notice that this entire term and this entire term, they're just going to be 0 because of x minus 1. And that'll just make that entire term 0. So it'll just be the c's. So it'll be c times, you just plug in 1. So 1 minus 2 plus 5 times 2 equals 2 minus 6 plus 14 plus 6. These two are going to cancel. This is just going to be c times 4 times 2 equals 16. And then it's going to be 8c equals 16. And then c equals 2. So there's one right there. And then similarly, we're going to plug in x equals -1. And so then that's just going to leave the d terms. Everything else is going to turn to 0. So then, besides the d term, and then the answer, obviously. So let's do that. D, and then it's going to be 1 plus 2 plus 5, -2 right there, equals -2, -6, minus 14 plus 6. It's going to cancel. and it's going to be d times -16 equals -16. And so d's equal to 1. There's that second answer. And then if we plug in x equals 0, the a's are going to cancel out because all the a's are multiplied by x. So it'll just be b, c's, and d's, but we already know what c's and d's are. So then this is going to turn into -b plus c times 5 times 1 plus d times 5 times -1 equals 6. Cool. And then we know that this is going to be, if we just plug in what we know for C and D, it's going to be plus 10 minus 5 equals 6. And then -b plus 5 equals 6. And so -b equals 1. So then b equals -1. Alright, cool. So then, now, to solve for the a's, we're just going to look at the third term right here, 2x cubed. So if you multiply, if you find all the x cubes, it should just be ax cubed plus cx cubed plus dx cubed. That equals 2x cubed. So we're going to use that. So it's just a plus c plus d equals 2. I'm just going to move this down here. And we already know what c and d are. So it's just going to be a plus 1. Oh, this is a 2 plus 1 equals 2. Then you'll see that a equals -1. Cool. So then now we can go back and rewrite this Laplace transformation is s squared minus 2s plus 5 -s minus 1 plus s minus 1 all over 2 plus 1 all over s plus 1. Cool. And so from here, you're going to want to do the Laplace inverse of both sides. So this is just going to be y on this side. And we're going to write the Laplace inverse of... Okay, we'll factor out the negative in the first one. So it's just s plus 1 all over s squared minus 2s plus 5. We're going to complete the square and make it this guy again. So I'm just going to rewrite that really quickly. And then the Laplace, 2 Laplace of 1 over s minus 1 plus the Laplace of 1 over s plus 1. Or the Laplace inverse. Okay. So we're going to do the two easier ones first on this side. So these two are just normal formulas from like 10.4, I think. Not 10.4. Was it? 10.3, I think. 10.3. So those are just kind of formulas you memorize or that you kind of can just look at in your notes. So we're gonna, or was it 10.2? It was 10.2. So it's just 2e to the negative, or actually this is regular t, right? Yep. And then plus e to the negative t. Cool. I think that's right so far. Awesome. So then for this side, you're just gonna do some, on the inside, you're just gonna do s plus 1. And then you're gonna do the plus 1, minus 1. I'll make that red. Plus 1, minus 1. Because you know that this is very similar to, it's a shift transformation, obviously, but it's very close to cosine of 2t. The only thing that's missing is s minus 1, so we're gonna do that. And then all over s minus 1 squared plus 4. And then this is just gonna be s minus 1 plus 2 all over s minus 1 squared plus 4. And you could just rewrite that as s minus 1 squared plus 4 all over s minus 1 and plus 2 all over s minus 1 squared plus 4. And then these guys are just e to the t, shift transformation, right there. Just moved e to the t, and then it's going to be cosine of 2t. And then this one's just going to be e to the 2t sine of 2t. Because this one deals with a constant in the numerator, and then this one deals with the function in the numerator. That's how you differentiate the two. So we're going to rewrite our big ol' answer. Don't forget the negative on here. So the answer equals negative e to the t cosine of 2t minus e to the t sine of 2t plus 2e to the t plus e to the negative t. Alright, and that's how you do it. Thank you so much for watching. Hopefully that wasn't too long, so have a good one, guys.